the revision session 2. We know in electromagnetic field theory, generalized law that governs electrostatics is Coulomb's law, and generalized law that governs magnetostatics is Biot-Savart law. We had seen a special case on this, which is method of images. And also, we had seen different case study under Biot-Savart law, considering it for a finite line at some random point and at radial distance, and also for a semi-infinite line and an infinite line. And also we have seen different types of forces previously. Force on a point charge given by Lorentz force equation, force on a current element, force between two current elements given by Ampere's force law. We have also seen this previously. We have seen force on a point charge given by Lorentz force equation as Q into E plus U cross B, and force on a current element by line integral of ideal cross B, of course, where ideal is equal to KDS is equal to JDV. And also force between two current elements is given by mu naught I1 I2 by 2 pi r. So this is what we had discussed in our previous class, previous revision session. We'll take further our revision into Maxwell equations today. First, we'll explain the theory related to Maxwell equations. Then we'll do problem solving. Okay. But before we do that, before we actually do that, what we do is we'll try to do some special problems related to this Biot-Savart law and forces. Then we'll start Maxwell equations. Okay. So let us solve this question. If a current element represented by, saying it is current element ideal given by 4 into 10 power minus 4 AY unit ampere meter is placed in a magnetic field of H, which is 5 by mu AX ampere per meter, then the force on the current element is asking force on the current element. Yeah. So try and solve this. Force on a current element. We know force on a point charge given by Lorentz force equation F is equal to Q into E plus U cross B. Obviously, you cannot apply this. You have force on a current element given by F is line integral of ideal cross B surface integral of KDS cross B volume integral of JDV cross B. Of course, you can apply this. We can apply this. And also we have force between two current elements. Force between two current elements is given by Ampere's force law. According to Ampere's force law, force is mu naught times I1 I2 by 2 pi r. So the formula that is apt for this situation is this. From this, F is line integral of ideal cross B. dF, because the limits are not given, you cannot apply the integral on that. So the small amount of force dF suitable for this situation is ideal cross B. So please do it and let me know the answer. Shall we have the timer on otherwise? Where is the timer? Anyone got the answer? You can type your answer. Is that completed? Can type your answer. So ideally, the formula is this. Okay, I want to find the DF. Given ideal is 4 into 10 power minus 4 AY cross B is, I want to find B. H is 5 by mu X ampere per meter. Mu times of H is B. Multiply with mu. It is 5 AX Tesla or Weber per meter square alternate unit. So cross B is 5 AX. So the force DF is 20 into 10 power minus 4. AY cross AX is minus AZ. This is DF is minus 2 into 10 power minus 3, that is milli AZ Newton. The unit is in millinewton. So it is minus 2 AZ millinewton. So your answer would be minus 2 AZ. Yeah. Is that clear? Everyone, is that clear? Yes. We'll go for one more very important question, examination point of view. Very important examination question. Yeah. We'll go for one more very important question. A very important exam question. Given an infinite current filament, lies at an infinite current filament lies at x is equal to 2, comma, z is equal to 4, lies at x is equal to 2 and z is equal to 4. This is x, this is y, right-handed system, and this is z. Now you have it at x is 2 and z is 4. So you have an infinite line. At x is 2 and z is 4. This is Z is 4. And this is X is 2. So this line where always X is 2 and Z is 4 is along which direction? Anyone? This line where always X is 2 and Z is 4 is along which direction? Yeah. Tanushree, Bhumika, anyone? Satvik? No, 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 no. That is why I asked this question. Tanushree. In this line, always X is 2, X is not going to change. Because you see, at this point, X is 2. And at every point on this line, X is 2. Okay. And always Y is 4. So this line that is existing is going along which direction? That's the question. Got it? On that line, X will never change, Z will never change. X is always 2, Z is always 4. So the line is in which direction? Where X and Z are not changing. Which direction? On this line, X will not change, Z will not change. Then the line is supposed to be on which in which direction, so that X and Z are not changing. Along which direction X and Z will not change? Yeah, Bhumika, Sashita, are you able to understand my point? I want you people to tell me the line is along which direction. Line is not in which plane, line is in which direction. In which direction X and Z will not change. Huh? Absolutely. Yeah. In which direction? Yes, of course, the Y direction. Y direction. It won't change in Y direction. When you are in Y direction, X and Z will not change. So that's why this line is carrying a current of 5 amps, carrying a current of 5 amps in Y direction. This line is placed along the Y direction. Find H at origin. A. Find H at origin. B. Find H at 4, 5, 6. So I want to find H. First at origin. H formula for infinite line. I by 2 pi r. R is the distance. Unit vector of the resultant. DL cross AR. So now you should find, this is the evaluation point, 0 comma 0 comma 0. Now we should find the source point. The source point is one which is the nearest to this 0 0 0 on this line. So the point which will be nearest and which is on this line, you know, x is not going to change, you know, z is not going to change. So it would be 2 comma 0 comma 4. This will be the nearest point. And now the distance, this distance between this source point and destination point is given by r. No, this is the source point, x1 y1 z1. This is destination point, x2 y2 z2. No, find r. Vector r is x2 minus x1 ax plus y2 minus y1 ay plus z2 minus z1 az. Vector r is 0 minus 2 minus 2 ax minus 4 az mod of r is under root of 4 plus 16 under root 20 ar is r by r minus 2ax minus 4az by root 20. So you got the ar ready now. I want dl. dl is dy ay. Unit vector dy is 1. So dl is ay. No. dl cross ar. Ay cross minus 2ax minus 4az by root 20 minus 2 of ay cross ax minus az, so plus 2az minus 4 ay cross az is ax by root 20. So whatever you got here is a unit vector, because if you do the magnitude it will be 1. So the vector that you got is a unit vector here. Substituting for h, h is equal to I by 2 pi r unit vector of dl cross ar 2az minus 4ax by root 20. I is 5 amp by 2 pi. R is under root 20. Minus 4ax plus 2az by under root 20. H is 5 by 40 pi minus 4ax plus 2az. Finally, the value of h is 1 by 8 pi minus 4ax plus 2az. This is h at origin. First bit. Second bit. Find h at 4 comma 5 comma 6. Now do it. Find it 4 comma 5 comma 6 everyone. Any doubt here? Any doubt so far? Bhumika, any doubt? Tanushree? Okay. Now find b at 4 comma 5 comma 6 and post your answer. Type your answer. Anyone got the answer? Tanushree, are you trying or shall I wait or shall I explain? Are you trying? Are the people trying? Very good. Nice, 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 nice. So I'll tell you the logic here. I'll tell you the logic. I want to find what h at 4 comma 5 comma 6. So let this point 4 comma 5 comma 6 is here. Now you must find the nearest point to 4 comma 5 comma 6 on this line, which will be of course 2 comma 5 comma 4, because x and z values are not going to change on this line. So then the nearest point to 4 comma 5 comma 6 is 2 comma 5 comma 4. Simple. So this will become x1 y1 z1. This will become x2 y2 z2. Okay. Now once I determine this point, the problem will be easy. Those are not started doing it, do it from this point. Okay. So this is x2 y2 z2. This is x1 y1 z1. We need to use this formula. Find r. So what is r now? X2 minus x1. 2x plus 2az mod of r, which is r, is under root 8. Ar is 2ax plus 2az by root 8. H is I by 2 pi r unit vector of dl cross ar. dl is d by ay. dl cross ar is dy is 1. Therefore, this is equal to ay. Ay cross 2ax plus 2az by root 8. That is 2 into ay cross ax minus 2az plus 2ax by root 8. Substituting minus 2az plus 2ax by root 8. So r is root 8. I use 5 amp. 5 by 16 pi. This will be 5 by 16 pi. 2ax minus 2az. 5 by 8 pi ax minus az. That will be your answer. You got plus az, Bhumika. Please check once. That must be minus az. In your answer, you mentioned plus az. That must be minus az. Please recheck. Everyone, is this clear? Okay. Good. So this is a very important model. So just go through it. Next is we'll start Maxwell equations. As you know, there are two Maxwell equations: electrostatics and two Maxwell equations in magnetostatics. In electrostatics, the first Maxwell equation is derived from Gauss law, also called Gauss law for electrostatics. The second Maxwell equation is from conservative property of electrostatic field. Third Maxwell equation is from Ampere's law. And fourth Maxwell equation is from non-existence of magnetic monopole, also called Gauss law for magnetostatics. So we'll discuss the first and second Maxwell equations first. We'll do related problems on this as a part of revision. Then we'll go for the third and fourth. As you know, the first Maxwell equation is derived from Gauss law also called the Gauss law for electrostatics. In simple, the Gauss divergence theorem also called the Gauss divergence theorem. So according to Gauss law, the amount of flux, amount of electric flux cut by any closed surface, the amount of electric flux, the amount of electric flux cut by any closed surface is equal to the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. psi e is equal to q enclosed. You know, electric charge is given in coulombs. And this is the very reason why electric flux is also given in coulombs. Both electric flux and electric charge are given in coulombs. They have the same unit because they are equivalent. And this is called Gauss law in true form. If someone asks you what is Gauss law in true form, Gauss law in true form is flux cut by any closed surface is equal to the charge enclosed by the surface. And this is the very reason why both electric flux and electric charge hold the same unit called coulombs. Is this clear? Okay. Yeah. Any doubt? Anyone?
చేయడంతో అక్కడి నుండి పొగ బయటకు చేయడంతో కొంచెం కంట్రోల్లోకి వచ్చింది సిచ్యువేషన్. ఇప్పుడు కొత్తగా ఏర్పాటు చేసిన రంధ్రంలోని రెస్క్యూ టీం లోపలికి వెళ్ళగలిగారు. ప్రస్తుతం సెల్లార్ లో దట్టమైన పొగ, విపరీతమైన వేడి నెలకొంది. సెల్లార్ లో చిక్కుకున్న వారి కోసం రెస్క్యూ టీం గాలింపు చర్యలు చేపట్టారు. రంధ్రం తవ్వి సెల్లార్ లోకి చేరుకుంది రెస్క్యూ టీం. దీంతో రెస్క్యూ మరింత సులభతరం కానుంది. ఇప్పటికే
Hey, what is wrong? Had I got disconnected? Something happened here. Can someone please confirm what happened? Somehow I got disconnected. Can someone tell me exactly what happened? Why there is a disconnected this thing? A guy logged in on your place. How? That's okay, but how? Who logged in? There was another sir who was connected. Okay, okay, okay. Why? By mistake? Okay. Is it by mistake, Tanushree? Let me connect. Okay. And I mean, is it the faculty? Is it a faculty who had taught you some classes or someone very random? Okay. Is it the same faculty who had taught some subject for you, or is a new one? Because just I need to escalate this. Is it a security breach or something? He was our faculty. Okay, fine. Then that's not an issue. Maybe he had pressed a wrong tab. Okay. They'll have access anyways. Huh? Fine. Okay. So we'll continue. Not an issue. So when he's asking Gauss law in true form, then you write psi is equal to charge enclosed. Okay. Now, how electric flux is related to electric flux density? We all know electric flux density is electric flux per unit surface area given in coulomb per meter square. If I consider a small surface area ds, flux associated is d psi e, then it is d psi e by ds. From this d psi e is d into ds, scalar notation. Vector notation, d psi e is d dot ds. From this psi e, closed surface integral d dot ds. This is how you relate electric flux to flux density. On the other hand, charge is related to charge density as volume charge density is defined as charge per unit volume coulomb per meter cube. If I consider a small charge dq in a volume dv, that is given by dq by dv. From this dq is rho v dv. From this q is volume integral of rho v dv. Now this is your RHS. When you equate this LHS to RHS, then you get closed surface integral d dot ds is equal to volume integral of rho v dv. This is called the integral form of Maxwell first equation. Applying divergence theorem on this, applying the divergence theorem on this, according to divergence theorem, closed surface integral a dot ds is equal to volume integral del dot A dV. This is your divergence theorem. Divergence theorem states that if you consider this A to be some energy source, for example, something like a light source, then the amount of light that is kept in this closed surface, the amount of light that is kept on this closed surface will be equal to the amount of light that is diverging into this volume. As simple as that. So applying the divergence theorem onto LHS, volume integral del dot A dV. Applying here volume integral of del dot D dV is volume integral of rho V dV, implies del dot D is equal to rho V. Divergence of electric flux density is equal to volume charge density. This is called differential form, point form of Maxwell first equation. Differential form or point form of Maxwell first equation. Now, if you want to, this is the end of Maxwell equation or Maxwell first equation. And if you want to apply Gauss law, if you want to apply Gauss law, you need to follow a procedure to apply Gauss law. The first thing you need to do is we need to define charge distribution. Second, we need to define a Gaussian surface. What is a Gaussian surface? A Gaussian surface is one which is symmetric with respect to charge distribution that we have defined. 3, take a point on Gaussian surface. 4, apply Gauss law. So this is a procedure to apply Gauss law. We will take an example to understand this. Let me consider or apply this Gauss law on point charge. The first thing we should do is we must define the charge distribution. So let us consider a point charge just like mentioned here. Let us consider a point charge Q at the center of a sphere of radius r. This is my charge distribution. I am considering a point charge Q at the center of a sphere which is of radius r. You must define a Gaussian surface. This sphere now becomes a Gaussian surface. The surface of this sphere is at equidistant from this charge. So I can say the sphere of radius r at whose center you have this charge q will act as a Gaussian surface now. So this will be a Gaussian surface. Next, take a point on this Gaussian surface. Let me take one point on this Gaussian surface. Now apply Gauss law at this point. Very clearly, the one that is going radially outward, the one that is going radially outward from this R like this is along the direction AR. So the electric flux density that is going out because I took a sphere, spherical coordinate system, will be dRAR. You know the general form is D is dRAR plus d theta a theta plus d phi a phi. But now D is moving radially outward, no d theta a theta, no d phi a phi. D must be dRAR. That's the first thing. Second, apply Gauss law. Apply Gauss law. Psi is equal to charge enclosed. Now, psi e, is surface integral of d dot ds is equal to. Can someone tell me how much is the charge enclosed, please? What is the value of charge enclosed? Someone, please. Yeah, anyone? How much is charge enclosed? That is charge of electron. Dinesh. That is charge of the electron. What you are saying? 1.6019 into 10 power minus 19 coulomb. In this scenario, how much is charge enclosed? Tanushree? Bhumika? Maniranjan? Satvik? How much is the charge enclosed? Can someone respond? In the given scenario, how much is the charge enclosed? You can see the diagram. How much is the charge enclosed by the Gaussian surface? This Gaussian surface very clearly is enclosing this charge q. The Gaussian surface is enclosing this charge q. But charge enclosed, correct, Bhumika. Charge enclosed is q. Now, RHS you got. I want to find the LHS. For that, I am finding D. We know D is DRAR. I need to find this DR. Okay. So that later on we can substitute that. DS, D is DRAR, as you know. DS, because this is spherical coordinate system, coordinates are r, theta, phi. We know the formula for DS. DS is mod of DS into normal. The normal to this surface is along AR. This will become AR. You know, length along R is dr. Differential length along R is dr. Differential length along theta is r d theta. Differential length along phi is rho d phi, but rho is cylindrical coordinate. And spherical equivalent is r sin theta. Therefore, this is r sin theta d phi. This is r sin theta d phi. Now, direction is along r. I got AR here. So that now the surface area is the product of these two differential surfaces. So you get the differential surface area by multiplying these two differential surfaces, which will result in r square sin theta d theta d phi into AR. That's your DS. So DS is r square sin theta d theta d phi AR. From this, d dot ds is AR dot AR will become 1 dr times r square sin theta d theta d phi. That is d dot ds. Surface integral of d dot ds is double integral dr r square sin theta d theta d phi dr into r square double integral theta 0 to pi phi 0 to 2 pi sin theta d theta d phi. This is dr into r square. Okay. Integral of sin theta minus cos theta theta running from 0 to pi integral of 1 d phi phi 0 to 2 pi 2 pi. This is dr r square into 2 pi. This is minus cos theta here. I can write this as cos theta limits pi to 0. This is dr r square into 2 pi. Cos 0 is 1 minus lower limit cos 180 is minus 1. 1 minus of minus 1, 1 plus 1, 2. This implies dr into 4 pi r square is equal to RHS cube. Implies dr is q by 4 pi r square. You know, d is drar. So it is q by 4 pi r square ar. You know, d is epsilon e. From this you get e is q by 4 pi epsilon r square ar, which is our standard equation. So this is true. And this is how you apply Gauss law. Very important when you are trying to solve a problem. You should understand how to apply it. In the exam, he may give an application where he will simply change these limits. You'll simply change these limits. Then you should know how to solve this. Okay, he may give you some other limits here. Then you should be able to apply it. He will give you some values of R and Q, substitute and get some answers. Okay. Is that clear? Hmm. Okay. So that is how you apply Gauss law. Do some problems on it. So this concludes Gauss law. We'll do some problems related to Gauss law. Yeah. Try and solve this. This is a question related to infinite line. Infinite line carrying charge density rho L. Uniform line charge density rho L. Electric field of such a line is given by rho L by 2 pi epsilon naught rho arrow. This is the base concept. This is the basic formula which you need to apply under this customized situation. This is 1/4 of a cylinder. As I cut 1/4 of the cylinder, the line at the center will come onto the right hand side. So this is the infinite line which is carrying charge Q. Just try to customize and solve this integral. Now this is what I told you. He'll change the limits and ask you, challenge you to solve it. So basically, we are interested in solving the integral E dot dA. To solve that, first you should find E and also you should customize the limits wherever it is required. This is what exactly I was talking about. You know the concept, but you should know how to apply this given a situation. So try and apply this. Type your answer in the chat box. Type your answer in the chat box. Type your answer. Anyone got the answer? Tanushree, Dinesh, Satvik, Maniranjan. Whatever knowledge you have, you need to apply here. What is saying? What is the electric flux? Because integral of electric field over a surface area will give you flux, as you know. What is the electric flux given by integral of E dot dA? Is asking us to find this answer. Integral of E dot dA is equivalent to surface integral E dot ds. So I need to find this, but I need to find the electric flux through a quarter cylinder. If I take a cylinder, I'm only taking the 1/4 of it. For a better visualization, let me take a cylinder. If you take this cylinder, I took only 1/4 of this cylinder. Not exactly. That is why a small change is required, Dinesh. See that question carefully again. Okay, if I consider this cylinder, draw an axis to it. Then this is 1/4 of that cylinder. If I only take this red portion, the center through which the charge is passing will be onto the right hand side like this. This shape is this shape. Okay, I took that cylinder. So the line charge density is going out now, is forming on the right hand side this way. And let the line charge density is Q and the height is H. So I want to find this integral E dot dA. For that, we will find E for an infinite line carrying line charge density rho L. E is rho L by 2 pi epsilon naught rho A rho. Given here rho L is Q. So here E is Q by 2 pi epsilon naught rho A rho. That's E for you. Find dA or ds. dA or ds. Mod of ds into an. Given that there now the normal to this surface, the normal to this surface will be along rho, which is along a rho. So an will be a rho. Now, I want to find the surface now. Cylindrical coordinate system. Coordinates are rho phi z. Length along rho is d rho. Here it is rho d phi. Here it is dz. It is along rho. So strike off this. Surface area will be the product of these two surfaces. Rho d phi dz into a rho. If I go for E dot ds, Q by 2 by epsilon naught rho a rho dot rho d phi dz a rho. A rho dot a rho is 1. One of the row gets cancelled here. From this E dot ds or E dot dA, Q by 2 by epsilon naught d phi dz. Surface integral of E dot dA double integral Q by epsilon naught d phi dz. No, Z will run from Z is height of this cylinder, which is H now here, 0 to H. Can someone tell me the limit of phi, please? What is the limit of phi? Zero to pi by 2. Absolutely 0 to pi by 2, because the actual limit is 0 to 2 pi. But in quarter of a cylinder, it will only cover up to pi by 2. In quarter cylinder, it will only cover to pi by 2. This is very, very important that you need to adapt to the situation that this is a quarter cylinder. You should not take the general limit phi is 0 to 2 pi, but you must customize the limit to the quarter cylinder, which is 0 to pi by 2. That is very, very important. This is integral E dot dA is q by 2 pi epsilon naught integral 1 dz z running from 0 to h, that is h here, phi running from 0 to pi by 2, that is integral of 1 d phi, that is pi by 2. This is qh pi by 4 pi epsilon naught. This is qh by 4 epsilon naught. That's the value of integral of E dot dA, qh by 4 epsilon naught. So your answer is the value of this integral is qh by 4 epsilon naught. And the most important thing is to customize the limit of phi to 0 to pi by 2 because it is a quarter wave cylinder. If it is a semi cylinder, the limit would be 0 to pi. The limit of phi used to be 0 to pi instead of 0 to 2 pi for a semi cylinder. This is quarter cylinder 0 to pi by 2. Please make a note of this point, which is very, very important, that how you customize the concept to the given situation. Clear, everyone? Go for the next question. Yeah, try and solve this. Everyone try and solve this. Got the answer? Did you got the answer? So what's the answer? Without solving, we can tell the answer. What is that? How? Very good, Dinesh. Had you solved it, or are you telling me? Are you telling me some logic? Did you solve it, or X direction in the line? Okay. So see here, very simple. Y is 3, Z is 5, means the line is along X direction. First thing. Now, if that is the case, then if you are finding E value, he got E value at 0, 6, 1. You want to find at 5, 6, 1. Now, at 0, 6, 1, if he is finding, the point will be the field intensity at 0, 6, 1 he wants. So, if you want to find 0, 6, 1, then the point on the x-axis will be 0, 3, 5, source point. Destination point 0, 6, 1. You'll get some answer. Let it be R. Let it be R. Now, in the second case, when you want to find it 5, 6, 1, source point will be 5, 3, 5. Because y is 3, z is 5 is not going to change. X coordinates will match. Now, again, if you find, you'll find the same value R again. This is x1, y1, z1, x2, y2, z2. x1, y1, z1, x2, y2, z2. If you do this, this is 5 minus 5, 0. So, all the coordinates are same. So, you'll get the same answer. So, whatever E you have, the same E you will get. You need not solve. You should not solve actually. Need not. It's not that you need not solve. You should not solve. If you sit solving this, it will take time. But if you understand the concept, logic is very simple. The point of evaluations are, for the first time it is 0, 3, 5 and 0, 6, 1. Second time 5, 3, 5 and 5, 6, 1. Therefore, R is going to be same. As R is same, the value that you're going to get will be same, because I want the E value. It will be rho L by 2 pi epsilon naught R. This is for a line charge. This will be rho L by 2 pi epsilon naught R into AR, or R square into R. This R is going to be same. As R is going to be same, the value will be same. So you will get the same answer again. Is that clear? Everyone, is it clear? One second. Yeah, we solve this bad sort law. So that's the logic here. Important model. Important model. If you solve it, you will waste time. You must do it without solving. You must do this without solving. Just apply logic. Finish the question within 5 seconds. Then time will be on your side. You will be ahead of others. Remember, in competitive exam, time is everything. Okay. Solve this. This is on surface charge. D is rho s by 2 an formula. Apply and find the answer. He is asking what is D at 6 comma 4 comma minus 5 caused by uniform surface charge density of 60 microcoulomb per meter square at x is equal to 8 plane. Plane is like this. This is x. This is y. This is z. Let this be 8. X is equal to 8. The plane is here. And the plane which you are talking about is the YZ plane, where the value of x is 8 everywhere. Therefore, it's called x is equal to 8 plane. And this plane is carrying a surface charge density of 60 microcoulomb per meter square. Is asking find the D value at, because this is 8, this will be approximately, this will be something x is 6 comma 4 comma minus 5. So at this point, if you want to find the electric field, D, D is given by rho s by 2 an. Rho s is 60 by 2. Already answer is in microcoulomb per meter square. You need not do anything with this. 60 by 2 an. 30 microcoulomb per meter square an. So what is the normal now? Because point is 6 comma 4 comma minus 5. normal from the surface, you draw it in this way. This is AX. This will be minus AX. So normal in this given case is AN is equal to minus AX. It will be minus 30 AX. This will be minus 30 AX. Option A is the answer. Now for suppose if the point instead of 6 comma 4 comma minus 5, point is 9 comma 4 comma minus 5. Now what is the answer? Tell me. So what is the answer? Someone please type your answer. Instead of 6 comma 4 comma minus 5, if it is 9 comma 4 comma minus 5, then what will be the answer? The point is 9 comma 4 comma minus 5. It will be above the axis like this. Then the normal from the surface will be this. The normal will be along AX. So now in this case, AN would be equal to AX. AN will be equal to AX in this place. So the answer would be changed to 30x. That's why you should always be able to customize your concept. Based on the point, the answer will change. You should be very careful. Okay. Any doubts here? Yeah. Is that clear? Okay. Solve this. Consider a closed surface S surrounding volume V. R is the position vector of the point inside S and N is a unit normal on S. The value of the integral double integral 5R A and ds. Yeah. Solve this. This is a problem related to divergence theorem. Hint is this is a problem related to divergence theorem. Solve it. Anyone got the answer? Apply divergence theorem. You know from divergence theorem, closed surface integral A dot ds is equal to volume integral del dot A dv. So try to apply this divergence theorem here. How to apply? Given this is closed surface integral 5r a and ds. This is 5 times closed surface integral r a and ds. What to do with this a and ds? Can I write unit normal an into ds as ds into an, more comfortable way? And we know ds into an is nothing but vector ds, because we know vector ds is mod of ds into an, which is ds an. So I can replace now with this a and ds with vector ds. This is 5 times closed surface integral r r dot ds. Applying divergence theorem, this is 5 times volume integral of r dot ds is del dot r into dv from divergence theorem. But you know r is a position vector. Position vector in the sense it is distance from origin. Distance from origin to some point P, which is x comma y comma z. This distance OP is vector r. Distance, when the distance vector is measured from origin, then you call it as a position vector. This is x1, y1, z1, which is at origin always 0 comma 0 comma 0. This is x2, y2, z2. Then the distance vector r or the position vector as it is measured from origin. If it is measured between 2 points, you call it as position vector. If it is measured from origin, you call it as, if it is measured between 2 points, you call it as distance vector. If it is measured from origin, you call it as position vector. As this is measured from origin, it is position vector. If I measure between 2 points, like if I take a point P1 and another point P2, P1 is at x1, y1, z1, and P2 is at x2, y2, z2. Then the distance between these two, P1, P2, is given by distance vector. You call it as R, is a distance vector. RD is a distance vector. Then the distance vector RD is given by x2 minus x1 AX plus y2 minus y1 AY plus z2 minus z1 AZ. Now you call this RD as a distance vector because it is a vector between 2 points. Whereas now these 2 points, one of the point is origin, then it becomes a position vector. Now the position vector is x2 minus x1 AX, which is in this case x1, x, y1, z1 are 0, 0, 0. Therefore it is xax plus yay plus zaz. So position vector R is xax plus yay plus zaz. Del dot R, del is dou by dou x of ax plus do by do y of ay plus do by do z of az. Del dot r is do by do x of ax plus do by do y of ay plus do by do z of az dot xax plus yay plus zaz. This is ax dot ax is 1, ay dot ay is 1, az dot az is 1, dot product element by element multiplication. Do by do x of x is 1 plus do by do y of y is 1 plus do by do by z of z is 1. This is 3. So the shortcut simply, because you don't know, this is 3 I'm explaining. Otherwise, once you know, in examination, you should never solve del dot r, because del dot r is always 3. You'll always get 3. You need not solve. So you got 3 here. This is 5 times volume integral 3 dv, right? 3 outside, 5 into 3, 15. Volume integral of dv is v. 15v. 15v. Therefore, option C is the answer. 15v. Therefore, option C is the answer. Is that clear, everyone? We'll meet in the next session, revision session 3 by 11:30. Thank you all.